Hey Algebra 1. So our video right now is about section 11.5. We kind of jump around a little bit in this chapter 11 and start with this 11.5 section. We talk about a couple things here. First, we're going to talk about qualitative versus quantitative data. So qualitative, I want you to think of the word quality. It's descriptive, like what are the qualities of something. Those are words you would use to describe. It's often adjectives. It's non-numeric in nature, which doesn't mean it can't be numbers, but we'll look at an example of that in a minute. Then we have quantitative data, which is numeric in nature. And so when we talk about numeric, I mean you could find the average of it, and that would make sense. Or you could add two of the values together, and that would make sense. So when we do some problems where we're asked, like example 1, to determine whether the following examples are qualitative or quantitative, we could start with sort of asking, is it numeric? All right, and so we look at shoe size of students at Deerfield High School. Okay, that would be numeric, right? Shoe sizes are usually numbers. And could you find the average shoe size? You could, right? That would make sense. It might be a little odd to do that, but it is something you could find the average of. So this is quantitative. B, types of books in the library. Right? Types of books, novels, mystery, nonfiction. Those are qualities, they're descriptive. So this is quantitative, or qualitative. Excuse me, qualitative. Favorite Chicago sports team. So again, that's not numeric. That would be qualitative as well. Seismic readings. Those are the earthquake measurements. You hear like that earthquake was a 4.7. That is a quantitative measurement because it's numeric. Next we have E, jersey numbers on the soccer team. So those are numbers, so you might jump to, oh, it's quantitative. But let's think about this. Would you ever find the average jersey number of all the jerseys on the team? Does that answer mean anything? It doesn't. Like, you wouldn't find the average jersey number. That doesn't make any sense. So this is actually a sneaky qualitative. Okay. And we're going to see another example of that in F, telephone numbers of DHS students. You wouldn't find the average telephone number. So even though it's a number, it's not numeric. It's still qualitative. So if you're confused or if you're unsure about whether something that involves numbers should be qualitative or quantitative, ask yourself if finding the average makes sense, right? Would you add up a bunch of telephone numbers and divide by how many students Deerfield had and find our average telephone number? No, that doesn't make any sense. So pause the video and try these 4 practice problems. Come up with qualitative or quantitative. So let's see. Part A, basic cost of monthly internet access cost. That's dollars. You could find the average of that. Your average cost, that would be quantitative. Quantitative. Breeds of dogs, that would be qualitative. Apartment numbers in an apartment building. Well, I wouldn't find the average apartment number, so that would be qualitative as well. And heights of students in a geometry class, that is quantitative. So see how you did there? This next one, this section talks a little bit about choosing the correct or the right type of display. And so whether you pick a line graph or a pie chart or a bar graph or a stem and leaf plot or a box and whisker plot, we want to make sure we pick the right type of display for those numbers. So here's a quick example of why it matters. Some people were asked to fill out a survey that said, what are all the things you're worried about in relation to COVID-19? And this is something where you could select multiple answers. And so we see that 62% of people said they were worried about family getting it, 68% worried about economy, 48% worried about themselves getting it. Those add up to way more than 100%. And that's okay. It doesn't mean this is a bad study. It means that a pie chart is not the way to do it, because the pie chart is always out of 100%. That would be if you had to pick one of these three, so the percents would add up to 100. But that's not what this one was done, so a bar graph is a much better way to display that data. And that kind of leads us into misleading graphs. So it's really important to be able to look at a graph and decide if it's an appropriate display of data, if it is misleading in any way. Sometimes graphs can be misleading in a innocent way, meaning it's just poorly designed. Sometimes it can be kind of more malicious, where it was intentionally misleading to try to get across a certain point that the data doesn't actually show. So things that could potentially be misleading about a graph: if it doesn't have a title, if the axes aren't labeled, those are ones you want to be careful. It might mean it's a misleading graph. Sometimes a graph doesn't have a great title, but it's labeled so well on the axes that it's clear what it's talking about, or vice versa. Every once in a while, you'll see a graph where the x-axis isn't labeled, or the y-axis isn't labeled, but it's spelled out perfectly in the title, and so it's not really misleading because of that. Maybe there's something else that's misleading about it. Here's a big one. Are the numbers on the scale evenly spaced? Does it begin at 0? Okay. If not, is there a break? Are all the components the same size in relation to each other? Is it displayed proportionally in a correct way? With the scale and the does it begin at 0? There's not always a right answer there. Sometimes we're going to see that beginning at 0 is actually a good thing, and sometimes it's a bad thing. It's all about what does the data actually show and how is it misleading in that way. So a couple of examples here. We've got this first one on the left. It's sort of like meant to look cool because it's 3D, but the perspective makes it seem like this 1998 number of singles sold is a lot smaller, but maybe because of the perspective and it's maybe not that much smaller than 1996. But so this would be kind of that last one. The graphs, the bars on the same size, so bad perspective. There's also no y-axis label at all. So we know it's the number of singles sold, but we don't know if those are like 10 or 32 million. We don't know. In example 2, there's no labels at all. So that's really misleading. But also, check out the y-axis. It skips around. It goes 1, 2, 4, 8, 16. So it's going up at an increment that is not equal. So y-axis not scaled evenly. When we look at this third one, notice the title: Massive Increase in House Prices This Year. And look how far apart they are. 1998 to 1999. It's a huge increase, right? Well, actually, it's only from 80,000 to 82,000. So it's only a $2,000 increase. But by zooming in on the y-axis and not starting at 0, it makes it look like the prices are a lot farther apart. So in this case, it's misleading that y-axis doesn't start at 0. And this is sort of a tricky thing to think about. So if we started at 0 and we had 80,000, then 82,000 would just be barely above it. And so your two graphs would actually look more like that. And you're like, oh, well, that's not really that big of a gain instead. Looking at example 3 here, describe how the graph is misleading, then explain how someone might misinterpret the graph. In A, and again, pause the video here, maybe try this on your own. So in A, I look at this, and where's 2009? It's missing. That's misleading. Were there 30 storms in 2009, and we didn't want to show that? Or were there 0 storms, and we just skipped it? That's misleading. In B, we've got, let's see, +3 plus, what is that, 8, +9, +5. Okay, so this is definitely not scaled, not to scale. That's problematic. All right, on the next 2 pages, we've got a bunch of examples. So what I want you to do, pause the video, just try these out. You don't have to write full sentences, but like circle some things that could be misleading, write a couple words or a few thoughts about why you think these graphs are misleading or what could be. And then we'll come back and we'll have some answers and talk about them. So let's go over a couple things real quick. Looking at number 1 here. So on the graph on the left, we've got the y-axis zoomed in, and so I mean, like you might even say like, oh, it looks like it doubled from here to here, but really it didn't. It only went up about $1,500. Similar problem in the right graph. Actually, our y-axis doesn't even go up evenly, so we go up by 2s, and then we start going up by 1s. That's really misleading, and it also is so zoomed in, even though it has a break here, like it's showing this giant increase, but again, that's only going up like 15 cents over the 8 years. In 2, seems to be a couple years old, I think, here, but the one on the right's better for the most part because this one makes it seem like Drake is running away with it, but look at the actual numbers. It's only about $1 million apart, and then 20 million to 14 million, that's like those two are really close. So here, this is a much better representation of their actual amounts of views. But in the second graph here, there's also a problem. It says top artist of the year, and it gives some numbers on the bottom. We don't know what those numbers are anymore. So neither of these are great. 3, here's a really good example of making the graph show what you want it to show, right? If we look at number 3 where it starts at 0, it sure looks like temperature is pretty steady here, like almost perfectly flat. But if we take that same data and we zoom in on right closer to where it is, we can actually see that it looks like the temperature's definitely increasing here towards the end from 1960 on. We don't really get to see that in this graph. So this is a way of an example of kind of choosing the graph to show a certain message, maybe. In 4, here's another version of that. I don't know if that's still blurry for you guys, but it's blurry for me. I'm not sure what's going on there. In this one, like the graph on the left, our national debt for the UK as a percent of GDP looks like it's increasing a lot lately, right? But if we zoom out and look at the whole history of it, we're still actually relatively low compared to what the percent was for a long time. So by just selecting this one portion of the graph, you can kind of construct a different message than if you had selected the whole graph. And number 5, lots wrong with this. Pie chart should be percents. These aren't percents, and they're not divided up evenly either. So, all right, that's all. Thanks.